Hello everyone. In this short segment, details related to performance test on pelton wheel, one of the experiments under fluid mechanics and hydraulic machines laboratory is explained. The aim of the experiment is to study the performance characteristics of a pelton wheel and to draw the main and operating characteristic curves. Here the performance is inferred with the help of main and operating characteristic curves. The apparatus required here associating the performance test on pelton wheel are pelton wheel, pump, venturimeter, and loading arrangements. The efficiency is mainly calculated, and the formula to calculate efficiency is output to input. Output power is brake power, and input power is input power. Whereas the input power, mainly a water power, is calculated by using gamma QH by 1000, which is also expressed in kilowatts, where H is head on the turbine, H is equals to 10 times P. Here we actually observe the P or the intensity of pressure, and later we convert the same in terms of head by using this formula. Q is the actual discharge, which is calculated and observed with the help of a venturimeter by using this formula CD into A1 into A2 into square root of 2GH divided by square root of A1 square minus A2 square, where H is the pressure drop. A1 and A2 are the cross-sectional areas at inlet and the throat. And finally, the output, which is brake power, is calculated by using 2 pi ng into S1 minus S2 into RD divided by 1000 into 60, where uh, N is the speed, S1 and S2 are uh, the loads, which are in kgs, and RD is the radius of brake drum. Let us go to the apparatus details. This is the pelton wheel test rig, where you have pelton wheel here, and there is a virtual reservoir from which water is supplied to the pelton wheel by using a pump, and pump here actually it induces some heads here. So this is the regulating apparatus for head. The pipe is called penstock. There is a venturimeter to observe the discharge, and the penstock supplies water to the pelton wheel through the nozzle here. There is a display board, and in the display board you can see very clearly there is a pressure gauge by which we observe the head on the turbine in kg per centimeter square. There is also an RPM indicator. There is a speed indicator. Uh, Certain other details related to the pelton turbines are also given here. Okay, so when it comes to pelton wheel, you can very clearly see the nozzle here and the buckets here. The loading arrangements, these are the manually held loads, and the loads are applied with the help of the wheel in terms of kgs here. Okay, the observations. So there are certain venturimeter details like diameter at inlet and diameter of the throat. They're given actually here, and the moment d1 is given, we can calculate area at inlet and also area at the throat. The coefficient of discharge is 0.92, and which says the discharge calculated is the actual discharge. RD, the radius of brake drum, is 0.116 meters, and venturi head is observed from the pressure gauges. At the same time, head on the turbine is also observed by using a pressure gauge, and loads are applied manually in brake drum. Okay, let us come to the tabulation part. There are two phases. One is constant head, and the other one is constant speed. Turbine speed is observed first, that is 1500. Pressure gauge readings, these are related to the venturimeter. So P1 at inlet, P2 at the throat, 5 and 4.8 kg per centimeter square. Now from this we directly calculate H, P1 minus P2 into H, directly in terms of heads. The unit is meters. Now, when it comes to loading, spring balance reading, S1 is 4, S2 is 0.25. Both are in terms of kgs. Head over the turbine, which are this 4.8 kg per centimeter square is observed from the pressure gauge on the main display board, which is 4.8, and the same is converted into head by multiplying 10 here, which is 48. Now Q actual is calculated by using the formula CD into A1 into A2 into square root of 2GS divided by square root of A1 square minus A2 square. So Q actual found to be is 0.00344. Input power is gamma into Q into H. Q is Q actual, H is head over the turbine. So it's around 1.6 kilowatts. And the brake power, which is calculated by using the formula 2 pi n G into S1 minus S2 into RD divided by 1000 into 60 is 0.669 kilowatts, and the unit quantities like unit uh, speed and unit power, which have the same units, 216 RPM and 0.002 kilowatts. Finally, efficiency is calculated. Efficiency is brake power by input power into 100. So it is around 41.2 percentage. Now the same is repeated in the constant speed phase. Just the change is turbine speed is kept constant. We just adjust the head in such a way that turbine speed is, in all the trials, it becomes 1000. So the same thing is repeated and efficiency is also calculated. Now by using the quantities, unit quantities and efficiency, we could plot performance curves here. It's a plot of NU versus QU, NU versus PU, and NU versus efficiency. You have two curves which are having a negative or a reducing slopes, and there is one curve, one straight line, which is parallel to NU.